Communications is section number 13 on FE Electrical and Computer Exam Specification, and it is commonly considered one of the most difficult topics on the exam. In this video, I'm going to go over the reasons why students find communications challenging when they're preparing for the FE Electrical and Computer Exam, and how you can go about effectively preparing for communications. Communications, like signal processing, appears in the second half of the FE Electrical and Computer Exam, which is the afternoon session. Students typically find the afternoon session of the exam much more challenging. According to the exam specification, there are 4 categories listed for communications. We have modulation techniques in the form of AM, FM, and PM. We have Fourier transform and Fourier series, multiplexing, time division, and frequency division, and digital communications. Let's start with amplitude modulation. At a very fundamental level, when the amplitude of the carrier signal, which is a high frequency signal, changes with respect to the amplitude of the message signal. When you dig deeper into math and theory, there is a lot to learn. Within my course, I have multi-part lecture series on amplitude modulation, where I go through in-depth derivations using different types of message signals and discuss single sideband and double sideband modulation. I explain the formulas with the help of multiple examples and connect the dots by using illustrations and diagrams. Ultimately, this is what's required for you to become confident and comfortable with amplitude modulation. And it also applies to frequency modulation. It also applies to phase modulation, both of which are categorized as angle modulation in general. By simply eyeballing the formulas that are given in the NCS FE reference handbook and hoping and expecting that you will encounter plug and chug questions can potentially be a very risky approach. And that's the first reason why students find communications challenging. Because to fully appreciate communications and all the underlying concepts, you have to understand the theory, connect it with math and visuals, illustrations to really understand the full picture. Then we have Fourier transform and Fourier series. At a very high level, you can convince yourself that the Fourier transform pairs are given in the reference handbook, Fourier series summation formulas are given in the reference handbook, and it looks like simple math. When a question shows up, I'm going to do plug and chug and deal with it. As you have probably noticed by now, there are multiple levels of understanding. In my program, I call them level 1, level 2, and level 3. The very elementary, basic level 1 understanding is that when somebody mentions Fourier transform, you recognize that it allows me to go from the time domain to the frequency domain and vice versa. You also recognize in level 2 understanding that there is a transform pair that is given in the reference handbook, and I know a couple of steps that will allow me to go from time to frequency and frequency to time. But level 3 understanding will help you recognize the difference between Fourier transform and Fourier series. You will be able to explain that Fourier series has limited application. Why? Because it only applies to periodic signals. And the fact of the matter is that most of the signals that we encounter practically are not periodic. A student with level 3 understanding will be able to look at a function which is visually provided to the student, translate that into its mathematical equivalent form, and then take it all the way to the frequency domain. There are at least 3-4 steps involved in this process. Recognizing the type of the function that is visually provided to you, putting it in its standard form, adjusting for any type of time shifting, applying the proper Fourier transform pair, and then translating it into the frequency domain. That's what makes this process challenging. Within my program, I go through multiple examples in the form of solved in-lecture practice problems, quiz problems with detailed solutions, homework assignments that are solved with my students during live training, and computer simulated mini exams. Even if you're starting with zero background in communications, you will be able to catch up very quickly. Then we have multiplexing, which actually shows up later in the FE Electrical and Computer Exam specification as well. Understanding the fundamental difference between time division multiplexing and frequency division multiplexing is just the start. But then connecting the dots in the context of, let's say, computer systems, multi-threading, parallel operations, bandwidth limitations really helps you paint the complete picture. And the last item is digital communication. The reference handbook does a great job in terms of providing you a lot of formulas, but then understanding them and applying them requires focused effort and lots of practice. And the final reason why communications is difficult is because power systems engineers don't deal with these topics day in and day out. Just like signal processing, you probably took maybe 1 maximum of 2 courses in communications, and that might have been a while back. I hope you found this video helpful. If you have any questions regarding communications or FE Electrical or P-Power exam preparation in general, feel free to drop them in the comments section and I'll try to respond to them as soon as possible. If you're looking for a streamlined exam preparation resource for FE Electrical and Computer exam preparation, then please check out my program at studyforfe.com. Thank you.